Hello, hi, my name is Gift and this is Tectenum. Welcome to the fourth lesson in our series of Beginner to Arduino. In this lesson, we'll tackle the ultrasonic sensor. So we're going to understand how the ultrasonic sensor works. We'll introduce it. We'll look at the sensor pinout. We'll look at how to connect the sensor to our Uno board, which is a sensor circuit diagram, and then we'll actually connect the sensor to the Uno board, and then we will see how the sensor works with the Uno board. So we'll illustrate it here with you guys. So jumping right in, an ultrasonic sensor is a sensor that uses sonar, which is sound, to determine the distance to an object. So the ultrasound transmitter in the ultrasonic sensor will emit a high frequency sound. The sound frequency ranges up to around 40 kilohertz, and then the sound travels through the air, and if it finds an object, the sound will obviously bounce back to the module, and then the ultrasound receiver will receive the reflected sound, and the difference between the time of transmission of the sound and the time of reception of the sound will allow for the calculation of the distance of the object. Okay, so once you understand how the ultrasonic sensor works, I think it is important to look at the pin diagram. So I'm just quickly going to share my screen with you so that we can see the pin diagram of the sensor. Okay, so this is the picture of how your ultrasonic sensor should look like. And we have 4 pins that are clearly labeled here. So this first pin is the VCC pin, and it works to power the sensor. So this is our power to the sensor. And then right next to it is the trig pin. And as I have just talked about earlier, the trig pin is the transmitter. And so this is what emits the high frequency sound. So this trig pin is the input pin. And then the echo is the receiver, which receives the reflected sound. So once the sound goes, it's reflected, it comes back. This is the output pin. And then lastly, we have ground, which is connected to ground. Then right here, we have an oscillator. And this is what generates the frequency of the sound that will be produced. So it's just like a frequency generator. So this, we can say, is the transmitter, and this is the receiver. Okay, so the ultrasonic sensor is as simple as that: transmitter, receiver, and then we have an oscillator to generate the sound frequency. Okay, so now let us look at the circuit diagram of the ultrasonic sensor. So what I was saying is this is a crystal oscillator, and as you can see here, it has been labeled 4.0. So this is just the frequency that is being generated. Onto the pins, we can see VCC is connected to 5 volts. That's the voltage that powers the sensor. The ground pin is connected to the ground pin, and then the trigger pin is connected to pin 7, and the echo pin is connected to pin 6 of the digital inputs of our Uno board. And that's about the connection. So what you're going to do is connect the ultrasonic sensor to our Uno board as following this circuit diagram, and then we're going to power it up, and then we'll look at the code. So now that we've connected the ultrasonic sensor as in the circuit diagram, we have connected the Uno board onto our laptop, and so the board is on. We're just quickly going to go through the code to understand how the code works, and then we're going to upload this code on our Uno board, and then we will illustrate how the sensor works. So we have defined the pin numbers. We've put trig pin on digital input pin 7 and the echo pin on digital pin 6. Okay, so we've defined the variables for duration and distance, and then we have set the trig pin as an output and the echo pin as an input. We're going to see our output on the serial monitor, so we have put in a line of code to start serial communication at a speed of 9600. Okay, so first we're going to clear the trigger pin, and this is the code for that, and then we're going to set it the trig pin at a high for 10 seconds, and then once that is done, we will read the echo pin, and the echo pin returns the sound wave travel time in microseconds. And then the variable that we had declared earlier will calculate the distance that has been covered, and then the distance that has been covered will be printed on the serial monitor as shown here. And then that's the end of our code. So let's just try and upload this code. Let us verify it first and see if there are any errors on our code. So the compilation is complete, no errors in our code, and if that's okay, then let us upload. The code is uploading, it is done uploading, so we can start our serial monitor. Okay, so let me put my hands here close by. It says the distance is 3. I've moved my hand up 34. I've moved it further up 71. Moved it back close 7. Middle 69. Up 72. I'm moving it down again 33. So it just calculates the distance that has the obstacle, how far the obstacle is from it. Right now I have removed my hand, so I think the next obstacle is the ceiling, so that's what it is recording right here. I have moved my hand really close. Now it's reading at 3. I have moved it really far away, so that is basically how it works. The hand is back close, and that is how it works. So that's it. We have we have finished on the ultrasonic sensor. So the ultrasonic sensor can also be used in automatic car or car robot. So if you're using if you have an autonomous car and you want it to be able to sense how far obstacles are, then you can integrate an ultrasonic sensor onto your project. That's it for this lesson. We have learned about the ultrasonic sensor, how it works, how to connect it, and we have been able to see the output of an ultrasonic sensor on the serial monitor. In case you have any questions or problem with your code, you can leave them on the comment section below. Please remember to like, subscribe, and share, and I'll see you in the next one. Bye.